Dart Skill presents special angles. There are two special types of right triangles you want to know about. One is called the 45-90 triangle, and the other one is called the 30-60-90 triangle. Imagine we have a right angle triangle and this is obviously the right angle of the 90 degrees. This angle is equal to 45 degrees and so is this. Reason why we call this a 45-45-90 triangle. Now because this triangle has two equal angles, it means that these two sides are also the same length. It's also an isosceles triangle at the same time. Irrespective of the actual lengths of the sides of the triangle itself can be big or small. It doesn't really matter as long as it's got a 45 degrees, another 45 degrees and a 90 degrees in it, in which the two smaller sides are the same length. So let's just call it x. X can be anything. And the hypotenuse in terms of x is always going to be equal to x multiplied with square root of 2. So if x is 1, which means these two sides are 1 units each, then the hypotenuse is going to be square root of 2 units. If x is 2, this is going to be 2 times square root of 2 and so on. And if we go on and call this angle theta, it doesn't really matter which 45 degrees is theta because they're exactly the same. So then this becomes the opposite and this becomes the adjacent side to angle theta. This of course is the hypotenuse. We know that sine theta, the sine function, is given by the opposite over the hypotenuse. So we have opposite over the hypotenuse, HYP for the hypotenuse. Cosine theta is equal to the adjacent over the hypotenuse, and tangent theta, written as tan theta, is the opposite over the adjacent. Now when theta is 45 degrees, we have this kind of a scenario, x times square root of 2. So we can say that sine 45 degrees is equal to opposite, which is x, over x square root of 2. The x and the x cross off, we have 1 over square root of 2. In the same way, cosine 45 degrees is equal to x over x times square root of 2. Again, the x and the x cross off, we have 1 over square root of 2. And finally, tangent of tan 45 degrees is equal to opposite x over the adjacent x, which is essentially equal to 1. For a 30-60-90 triangle, as the name implies, it's a right triangle in which you have the right angle of it. One of the two other angles is a 30 degrees and the other one is a 60 degrees. It has to be because the three have to add up to 180 degrees. Just like we discussed for 45-45-90 triangle, no matter what the actual lengths of these sides are, if we have the side opposite to the 30 degrees as x, the hypotenuse is always going to be 2x provided it's a 30-60-90 triangle, and the side adjacent to the 30 degrees is always going to be x times square root of 3 no matter what x is. And now if we set theta to be equal to 30 degrees, then this becomes the opposite and this becomes the adjacent. This obviously is the hypotenuse, that's fixed, that doesn't change. So we have sine theta or sine 30 degrees is equal to opposite over hypotenuse, x over 2x, x and x cross off, we have 1/2. In the same way we have cosine theta or cosine 30 degrees is equal to adjacent over hypotenuse, which is x times square root of 3 over 2x, cross off the x and the x, we have square root of 3 over 2. And finally, tangent theta, or tangent 30 degrees, theta is equal to 30 degrees in this case, is opposite over adjacent. When this is theta, opposite is x, adjacent is x square root of 3. If you divide this with this, cross off the x with the x, you have a 1 on the top, so it becomes 1 over square root of 3. And to do the same for the 60 degrees, now let's set the 60 degrees to a theta. When this is the theta, then obviously this becomes the opposite side to angle theta, and this one becomes the adjacent side. So we have sine 60 degrees is equal to the opposite over the hypotenuse, x times square root of 3 over 2x, which is equal to square root of 3 over 2. Cosine 60 degrees is equal to adjacent over the hypotenuse, which is x over 2x, which is 1/2. And tangent 60 degrees is equal to opposite over the adjacent, x square root of 3 over x. That gives us square root of 3. You would really do yourself a huge favor if you could remember these trigonometric functions of these special angles.